Hi there, I'm Bob. This is Shyam.
Hi.
We both do a lot of work on SIG scalability as part of the Kubernetes community. So we did a session like this at KubeCon Austin, the last one, and we came in prepared to do more of a developer discussion, and we had a whole deck and just stuff we were going to talk about. And what happened was a lot of people who were not really like core developers wanting to talk about scalability showed up. A lot of people interested in building and running large clusters showed up. So we decided that we would take the lesson and kind of shift the discussion today to be more in that direction. But here, let me go ahead. Here, so the idea for the session was to kind of introduce SIG scalability, provide some general education around how the project thinks about big clusters, how we do testing, really want to kind of be oriented towards operator concerns and questions. We'll try to keep it a little bit on the short side, so if there's Q&A, last time we discovered there was lots of Q&A people wanted to talk about, and then we ended up getting thrown out of the room because people wanted to hang around and talk about big cluster operations experience. So with that, we'll move along. Okay, so just a update on SIG scalability. So if you're interested in big clusters, SIG scalability is a great place to show up and talk about things and ask. So this is the working home. By the way, the SIG scalability is was the first Kubernetes SIG formed. Has been going on continuously. Yeah,
I didn't know that.
Yeah, Joe Beta and I were the first we created. In fact, it was a SIG before we started calling them SIGs, and then we had to rename it.
Okay. Cool.
So, one of the really key things is setting SLOs. Like, well, of course, as a cluster gets bigger and more stuff on it, it may get a bit slower and slower. Well, what's too slow? So, I think Shyam's going to talk about that in a bit. Primarily concerned with control plane design and configuration. So, not nodes, right? So there's different. You could think about really big nodes, and nodes starting containers is a performance issue, but SIG scalability is more concerned with how do you build the control plane to run these kinds of clusters. So the concerns are number of nodes, pod services. Really not concerns are things like nodes and multi-cluster. As you might expect, there's a very heavy crossover between SIG scalability and SIG testing. And of course, practically speaking, there's some very critical systems design things within a Kubernetes system, like how is your etcd cluster set up and configured. So moving on. Just logistics, if you're interested in joining the meetings. So we meet bi-weekly Thursdays. This is essentially just before, every 2 weeks, just before the main community meeting. Links here. You can always find me afterwards as well. This is all in the Kubernetes community project as well. So if you want to go and look at the lists of SIGs. And also, there is a group, but most of the action's on Slack in terms of discussion between people. So, all right. With that, I will hand it off to Shyam.
Yeah. So hi, I'm Shiyam, and I'm one of the developers very closely working with SIG scalability, and I'm an engineer at Google. Before going this, actually, I wanted to add a couple of points here. Like one of the things which often happens, and like I see happening, is like auto scaling is also not a concern. Like auto scaling doesn't really fall into the purview of scalability, and there are a lot of questions and people looking for auto scaling related questions. So this is not really going to address that stuff around that. And I also want to highlight the fact that scalability, as I see it, is more of a horizontal effort. So we are having a very big crossover with other SIGs because we are trying to like monitor and improve performance of various components and like test stuff out across different components in the cluster. There are verticals, and so for example, if you're looking for something like performance of different network plugins, or trying to understand the performance of, let's say, custom schedulers, or trying out different container runtimes, and these kind of fall under separate verticals and usually different SIGs. We are trying to facilitate them with scale testing and often consult them with performance-related stuff, but we are not actively testing out different configurations. We are usually testing out a kind of a core plain vanilla Kubernetes offering. So I'll probably start by explaining what is our role. Like one of our roles is basically to perform scalability testing, more so as part of CI in the Kubernetes project. And every release, we are running a set of tests, and we run tests at different scales, starting from 100 nodes all the way till 5,000 nodes, and across different providers. Uh, it's not a very exhaustive list, but we are right now running our tests mostly on GCE and some on GKE. And there's also a framework called CueMark that I will come back to later. It's kind of a cloud provider agnostic way of let's say, running scale tests using simulated clusters. They are lightweight, but they offer a lot of signal on the control plane scalability. And yeah, so these tests are really important. They're blocking the release, the Kubernetes release, and usually we kind of face some major issues every release with some aspect of scalability screwed up, and we're trying to fix it and make things really production ready in the project. So yesterday, while I was talking to Bob, I kind of was talking about this mental model. The name performance envelope was coined by Bob. I was thinking more along something like a scalability space or something. So there are different dimensions in which you can try to run the cluster, like try to push the cluster towards its limits. So, for example, you have the number of namespaces, the amount of churn you can create in the cluster, the density of pods you can run, and different stuff. So the way it works is like a lot of these limits are you can think of them as absolute limits in terms of like if you had to keep if you had to keep other things under control, then you can tweak this to its maximum. But you cannot have all the maximums at the same time. So it's kind of like a subspace in which you have the guarantees of our SLOs. I'll go through what the SLOs we currently have later on. But yeah, for example, we say we support 5,000 node clusters, and we also say we support 30 pods per node, 100 pods per node, like officially, but we don't support both of them simultaneously, which is like 5,000 nodes and 100 pods. So for example, the 5,000 node stress tests that we are running have like 30 pods running per node, and the reason is that like simultaneously stressing out on all the different aspects can like affect the let's say the performance and the control plane significantly. Another example is like we say that we support close to 10,000 services, and then we also say we support 1,000 endpoints, backends in a single service. But if you try to run like 10,000 services each with 1,000 backends, the control plane will most likely not be able to take this load. So yeah, so these are a few examples. So yeah, that's pretty much what I wanted to say here. And this is what I was saying earlier, that if you want to like really skew towards one particular limit, you probably will be more limited on other fronts. So you have to, when you're designing your own cluster, as a user, if you want to like really start a big cluster, you need to carefully consider these factors. Like, what are the things that you're going to most use? What is the kind of churn you're going to create? What are the most, how big are your nodes, and like, what is the density you want to have pods within, things like these. And we are usually consulting people on like what are the things that they will need to keep in mind when doing such things, and the limits and stuff. And if you are looking for creating large clusters, you probably and have some questions, you probably should contact us on Slack channel. We have a Scalability Slack channel. Yeah, and yeah, this is more about the testing that we are performing. We have a test grid, which is kind of like for now, it's mostly like a very limited knowledge. Only limited set of people know what exactly we're testing, and we probably should. One of the things that we want to do is like make this more open and make this more visible to people. Like, what are the configurations we're testing, and what are the different things that we're measuring, and part of that is like the scalability release validation process that we introduced like a couple of releases back, where we are for each release we are giving a spec of what is the configuration we tested out. And it's like I was saying earlier, it's mostly a plain vanilla configuration, because you cannot really test out on all combinations across each verticals, because then you'll have a combinatorial explosion of cases to test. But if you're interested in testing some particular feature, or like you're interested in looking like how does a particular configuration perform, we might be able to assist you on the Slack channel or through our mailing list. Yeah, so the test grid it's mostly about our tests, but maybe I can quickly show you the performance dashboard where we display all the results of our performance runs. So this is just an example graph where we are kind of running benchmark tests against the scheduler and like seeing what is the latency of the schedule operations. And there is a array of different combinations like of tests that we're running. Like I was earlier saying, we run on GC, mostly on Google Cloud, actually pretty much almost completely on Google Cloud right now, all the tests. And we hopefully will be having these soon on other clouds as well. So yeah, so this is, for example, let me show maybe, yeah. So this is, for example, the pod, what's this, sorry. Yeah, this is the 100 node cluster test where we're running our density test. We primarily have two tests. One is the density and the other is the load, which is not so exhaustive as you can imagine, and there are probably more stuff that we can test out. So the density test is basically about creating a big cluster and densely packing it with pods, and like basically 30 pods per node, and then creating additional pods and measuring how quickly, what is the latency of pod startup. And that's where our first SLO comes, which is the pod startup latency SLO, where, so in Kubernetes, we are officially supporting a 99th percentile of less than 5 seconds of pod startup. And this does not include the time to pull the image, because that is image variant. This is across runs. So this is part of CI, so we are continuously running it against the head of the Kubernetes master branch and even other release branches. And yeah. So this is where you can find quite some useful information. For example, you can also look at what is the, let's say, the maybe etcd. Yeah, that's the wrong etcd. Yeah, so for example, you can look at the resource usage of control plane components. For example, this is how the etcd memory and CPU looks like. So if you plan to start a 100 node cluster and kind of have this much of density, and then you probably can expect the memory usage of etcd to be within this range. Of course, it can vary on several other factors, like what is the kind of requests you make and like how frequently you do stuff and things like these. So yeah. And the other thing is we're also collecting performance profiles of various kind of things, and this is part of our bigger effort to develop more tools to be able to measure and understand performance and like have a better understanding of how these components are working. And like part of that is collecting, let's say we're collecting the CPU and memory profiles of the API server, and we soon plan to have this more extensively covered. Yeah. So these are tips for cluster ops. So if you're actually planning to start a really big cluster, then there are a few things that you need to keep in mind. This is not close to being exhaustive, but these are just few things that we came up with while creating the slides. And you probably would want to read Scalability Good Practices doc, which has more details about what are the things you should keep in mind. So a few examples are, let's say, this is actually the first one is based on a real life incident, I think, which we saw a few days earlier. So if you're creating a lot of jobs and the jobs are like frequently getting finished and there is a huge throughput of jobs you're creating and they're finishing, these job objects don't naturally get deleted, which is kind of a problem that is specific to jobs because they usually run to completion. And over time, these jobs start occupying a space of your HCD, and this can eventually cause memory outage issues for HCD. So you probably want to like clean them up. Uh, yeah, and another thing which is also kind of happens from time to time is like spamming API server with a lot of calls or some particularly heavy calls. So, for example, if you're trying to list all the events from a cluster, events are like in huge numbers, and they're like emitted by almost all the control plane components at a reasonable rate. So if you try to list all events, this can be really heavy for the API server because there are just many of them. And like I've seen, for example, calls where like list all events lasts for as much as 45 seconds. And you need to remember that when such long calls are happening, you're kind of like taking away a part of the API server's resources, more specifically the API server buffer for requests. It has a limited buffer, and it can only have as many as those requests in flight at any given point. So such long calls can actually take up the buffer. So as a user, when you're operating the cluster, or even you have some components which are talking to the API server, you usually want to be careful about not creating too much pressure on the API server with calls. So these are things that are potential areas of works. For example, one of the things is we would probably want to have some kind of rate limiting for calls, for API calls, so that people are not able to, like one single client or maybe a set of clients cannot alone overwhelm the API server. And for example, the first one where like we are creating a lot of objects of a particular type, one of the things we probably would, one of the ways to solve it is have proper quotas in place to be not able to create too many objects in your cluster. So yeah. And yeah, the more important part in this slide that I want to talk about is CueMark. So we have this framework called CueMark, which is basically our way to perform large cluster tests without actually starting large clusters. So this is like a simulated cluster where you start a Kubernetes master separately, but you don't really create real nodes, but you actually fake them. So you create what we call as hollow nodes, which are basically pods on top of another cluster. And each pod has a hollow version of kubelet, kubeproxy, and basically the node agents, hollow versions of those which actually don't do real work, but they still talk to the API server as if they're real components doing real work. So by this, we're able to actually start really big clusters, which is as much as 5,000 node clusters on like an 80, it's something like on 700 cores. So if you're a user trying to test performance of something and you don't have access to too much quota or too many compute resources, this is something you will probably want to try out. And I've seen people increasingly showing interest in this. So initially we had this it was possible to run this only on GC, and then we made it kind of cloud provider independent. And then there are a couple of people who even tried to do this on-prem. Yeah. So yeah, the first doc has a few more important pointers, things to keep in mind when you're actually trying to build a scalable cluster. And the second one is a doc I recently wrote. It is basically kind of a composition of small stories around what were the kinds of scalability regressions that we saw in the past in the project. And scalability, like I was saying, is a very cross-cutting area, and a change in any particular component of the system can potentially break the scalability of the entire cluster. And scalability in that sense is actually a very sensitive characteristic. So, for example, let's say if the kubelet starts making one extra call, let's say every 1 minute on a 5,000 node cluster, this is like 5,000 calls every 1 minute, which is like, I don't know, close to 180 QPS or whatever. So you're adding a whole lot of QPS on the API server. And yeah, so in general, there are very interesting cases there that you might want to look at, and that also kind of demonstrates like how SIG scalability is kind of collaborating with other SIGs on areas of work, especially around performance, and like trying to point out to other SIGs that, okay, this is causing an issue, this particular thing doesn't really scale well. And so, yeah. And the other thing that Bob initially mentioned, which we are quite closely associated with, and we actually own the SLIs and SLOs for Kubernetes. And like the first SLO that I already mentioned earlier was to have a 99 percentile of pod startup latency less than 5 seconds. And the other main SLO that we have is having an API call latency, 99 percentile of API call latencies across call types to be less than 1 second. So for each kind of call, let's say get pods or like get secrets or all these, so 99 percentile of each kind of call should be less than 1 second. And this is the other test that you are performing, which is called the load test. And yeah, so those are basically the two SLOs we have. In general, we realized that these SLOs are not completely informative, and in most cases are not enough, because there are some aspects of the system which are not completely covered or that are left out by these SLOs. And it's possible to have scenarios where the SLOs are kept up, but still there's something going bad in the cluster and something really bad. So one of the fronts that we are working on is trying to define new SLIs and SLOs which are more fine-grained and cover different interactions in the system. And Wojtek, who is our other SIG lead beside Bob, is like doing quite some work on this, and he's come up with a proposal for a set of SLIs. And this doc, so if you're actually trying to know what are the limits of various kinds of objects we can have in Kubernetes, then this doc is kind of, as far as I know, the one main source of truth. So like I've said, this again is kind of like, this basically shows the limits along each front, but not like a combination of all the limits. So yeah, you might want to take a look at this if you're trying to like use really big clusters. Yeah, so this is about what do we plan to do in future, some high-level areas of work. So one of the things that we're keen to look at is like having tests that are running real workloads, as opposed to like simple tests that we are running right now, which is just starting pause pods and not really measuring performance in more realistic production-like setups. We're actually trying to up the game by not doing this ourselves, but actually by trying to create a tool. There's this tool called Cluster Loader that we are trying to work on, by which we want to like empower normal developers to be able to start their own workload, to perform their own load tests, be able to configure what is the kind of things that you want, like what is the kind of test you want to do, what exactly do you want to load test. So if you're really interested, then interested in load testing some particular setups, watch out for this. This is still kind of in the design phase, and like we're still thinking out about the design. Yeah, and the other thing I already mentioned is having more improved and better SLIs and SLOs. And the third main area is developing tools and frameworks, which basically help us uh, understand understand at a better detail the tiny aspects of performance and like be able to understand what exactly is happening at different places and uh, what was the other thing? Okay, I can't remember that. Anyway, so yeah, so we want to have better tools and better frameworks to be able to measure things and do scale testing better. And yeah, Bob, would you want to talk about Sonobuoy because I have close to zero idea.
So this is Sonobuoy was something that the Heptio folks have been working on for a long time. It's long time in Kubernetes years. Sonobuoy is the framework that's used for conformance testing, but it's really a general purpose framework that can be used for different kinds of testing. And so one of the things we were talking about this week even was being able to use Sonobuoy with a focus density argument to run these kinds of scale tests so that you could have an existing cluster, and just like you could run conformance against that cluster and get conformance results, you could do the same for a performance result. And the idea here would be, this is kind of along the line of tools and frameworks for empowering users to figure out what's going on in their own clusters with regards specifically to these kinds of scaling tests. So I think that was is that our last slide?
Okay.
I think so.
Okay, yeah, that's pretty much the last slide and more or less a description of what we have been working on and what we're planning to work on. So yeah, I guess it's time for questions if you have some questions or concerns about scalability or performance. You can.
Obviously, you've got a lot of scalability testing you're running on the sort of CI/CD basis. Do you run any of them for sort of longer periods of time to measure how things vary, sort of, over days, hours, days? I imagine that those are kind of short-running tests in the amount of time and the number of times you run them.
Oh, we do have longer tests as well. So okay, so maybe I should.
Clarify one thing. Like, not sure what exactly you mean by short test. The test on like 5,000 node cluster takes like 12 to 15 hours.
Yes.
This is like you can treat it as short or long.
Yeah. I mean, I'm talking sort of sometimes days, I guess. Or
So,
Yeah.
so we are not running any like solid
reliability. Sort of.
Mm-hmm.
What exactly is the story today around rate limiting? There is no rate limiting mechanism per se in the API server, right? So what are the recommendations you guys have for implementing rate limiting today, and what is the, let's say, medium term or like near to medium term plan upstream for that?
That's a good one for you. Here,
What I
you wanna,
know.
So basically, yes, there isn't really good.
there you go.
There isn't really good story for rate limiting now. The only rate limiting that we are currently doing is like client-side rate QPS limits and number of in-flight requests in API server. We would like to do something like rate limiting based on like usage or amount of resources that API server has, but that's not even yet designed. So I don't expect it will happen anytime soon-ish. That's the plan that we have like medium long term, but I can't promise it will happen when it will happen exactly. So we still like don't have very good solution for that.
Follow up with another question. So ideally, you would want at least the qubits to have some sort of capacity reserved on the API server to meet certain SLAs of the cluster as a whole, right? You don't want like interactive or like third-party clients browning out your qubits from being able to access the API server. Will you say that partitioning separate deployments or like separate fleets of API servers to serve the qubits and the external clusters is a reasonable solution near term until rate limit is in place. So you can provide at least SLAs for your kublets and have the cluster be in a more consolidated state.
Yeah, so I think that at least short term, it sounds reasonable. More longer term, we would like to have at least things like fairness with respect to API calls. We would like to have priorities of API calls. For example, like node heartbeats should have some higher priority, because like if nodes or kubelets are not able to send heartbeats, then it can, for a longer time, it may result in pod evictions, which is like obviously a bad experience. So there are a couple things in the like area of rate limiting, or whatever we call it, that we have in mind, but we don't really have capacity to work on.
Is AWS planning any of the Coral rate limiting mechanisms on top of API server? AWS servers?
I was just sitting here thinking that would probably be a good idea. So I think there are some ways here to improve that. The other thing that you probably noticed on the screen is that most of the test grid is presently GKE or GCE, and that's another area that we're working on improving.
So you were trying to share some numbers on number of nodes. You have kind of same numbers for like pod churn, for churn of pods. So
Could you repeat your question? Sorry, couldn't get it.
I was kind of wondering, like, if you have a high churn of pods, how would that affect the system?
So, like, in general, when there are a lot of pods that are coming up, there are things that are associated, the operations that the control plane does, which kind of, like, I would say the primary aspect is, like, one main aspect of it is the kind of calls that are emitted as part of this process of starting pods. And some of them are, for example, kubelet posting statuses, like pod statuses, and like emitting events for different parts of the pod startup lifecycle. And like if you have a really huge churn, then there can be like many kubelets from across the cluster that are trying to simultaneously send a lot of this. And actually, like from my experience, I've seen a case where like someone was trying to like upgrade a deployment, and a really huge deployment, and they kind of upgraded it without having any limits on max available or max unavailable or whatever, which basically led to a situation that a huge number of those pods are being deleted and created, which kind of like hurt the API server, and I think more specifically the HCD. HCD couldn't cope up with so many requests. So like, yeah, we really kind of suggested them to have a limit.
But
Number of how many, the level of churn that's supported within the P99.
so in a healthy situation, I would say that like you are kind of limited naturally, because for example, like there's like QPS limit in scheduler of set to 20, which means that you won't be able to start more than 20 pods per second if they are like scheduled by the system. Obviously, like if you create manually pods that are already like assigned to some nodes, then you will be. But in majority of healthy situations, the throughput that like Kubernetes supports is currently at the level of 20 by default, because those QPS limits are like tunable. So yeah.
How high can you crank that number?
That is a good question.
We are pushing that to 100 in our 5,000 node tests. But for production, there may be some cases that we still have not explored enough to be able to confidently promise that 100 will work always. So we are kind of bumping the QPS to 100 in both controller manager and scheduler to basically quickly create pods and quickly schedule them.
But that's because those are pause containers as well. It's kind of a synthetic case. So in a real system, you would expect that you're not going to actually be able to start the containers. Like if you're going to pull down if you're going to be pulling down container images, that your total system is probably going to be dominated by that. Maybe not.
But yes, so also to add to this, like there isn't any one single universal answer to this, because it really depends like on how big the cluster is, like how big your master machine is, or whatever machine where your control plane is running. If throwing more resources helps with many different components here. So I would say that probably for like relatively small clusters, we can go even higher than 100, even now if you throw enough resources to control plane.
So I have different questions. So what is, how do you feel your goals for like scalability in terms of number of nodes?
You know, I had this on the slides to begin with because this one came up last time as well. And I think this inevitably leads to discussions of, well, what is a big enough cluster? And I think this is something we want to continue to get feedback from the user community on.
Yeah.
At the 5,000 node cluster level, you're starting to trip across two factors. So one factor is the number of companies or groups that are actually interested in running at that scale. And the other is you're starting to trip across like failure domain considerations. You know, you're talking about a lot of eggs in one basket, and you're probably starting to get into the zone where you should be thinking about a multi-cluster design. And really, this whole conversation, really at that kind of scale, you should probably be testing, like understand exactly what your profile is in terms of container starts and nodes and these other characteristics, so that you're able to qualify the configuration you're using to ensure that your production system is working properly. But this comes up. I mean, we have. I think at the last session in Austin, we had people asking about 25, 30,000 node kinds of systems.
Yeah, I think we even had a quick hands up of like one big cluster or many small clusters, and do you remember like it was skewed towards one of them, and I don't think it was one big cluster.
Should we do the same? So like, how many people here think they want to run more than 5,000 nodes in a cluster?
Or something of the order of
Or
thousands.
something, thousands. Like, well, let's try. So let's go to 1,000 nodes. Looks like 750, 100 nodes. How many people? Yeah, so we've got I mean, even in this room, right? I mean, we have very steep drop off. But that said, it is a good point, right? I mean, there are definitely operational advantages you get by running fewer, bigger clusters. So that does tend to skew things maybe in the bigger direction over time. Are we? Right.
Yeah. Josh had a question for a long time.
Yeah, so when a lot of the performance tests are failing, as they are right now, what's the process for getting that resolved?
Yes, that's a very good question. And this is a discussion we've been having. But maybe we can take this offline, Josh, if this is like very developer centric, because this is a long discussion, and there is no well-defined, like a too well-defined process right now. We just have like scalability release blockers, and just some time close before the release, we're like trying to like put all our energy into it and fix stuff, which is not the best way to do it. So there are processes we are introducing to like adding scalability pre-submits and deflaking our post-submits, and there are a few efforts along those lines. But yeah, we should probably talk about it in more detail later.
I think the scalability pre-submits, which are not going to run at the like 5,000 node level, I don't.
Oh yeah, yeah. So the scalability pre-submits cannot be like 5,000 nodes,
right,
because you can't afford to run them fast and at that rate.
They still should probably catch some.
Yeah. So we have like 100 node tests and 100 node scalability pre-submits, and they're already running now. By the way, they're just not blocking the submit queue, but yes, they should catch a good number of regressions, hopefully.
I think that generally the problem is that our tests are super flaky. It's not that they are consistently broken, which would be easier to fix probably. It's flakiness ratio, and like unflaking test is like one of the priorities that like we have.
Yes.
All right, I think we're out of time. Or quick double check here. Maybe one more question?
Quick one. Based on the profiling that you've done on the control plane components, can you make recommendations collocating certain control plane components as opposed to non-collocating others. Like, ideally, you'd want to have I/O bound collocated with CPU bound so that they don't compete. Do you have any recommendations in that area? Like, which control plane components are better collocated together on the same node versus which ones?
We have a recommended provider config, but I don't know if that's super updated. But in
It's
general,
relatively up to
in
date.
general, actually, we don't test too many configurations. But maybe you have something.
In general, we are running everything on a single machine.
Yes.
Or
We're running-
like either like single master machine or like couple masters, but then still all the control plane components are running on a single machine. I mean, we are not splitting, for example, etcd to separate machines or like schedulers or other things like. It really depends on the environment. Like if for example your IOPS limits are bounded to the machine itself, then potentially yes. Like we have, since we are doing this on GCE, we can tweak some of those at least independently. Like for example, IOPS are strictly correlated with the disk size, which is independent from the CPUs. So we can throw more IOPS by increasing disk size, and we do such stuff, and like so.
And
so it really depends, like what are your constraints of your environment. So in general, yes, in some environments it makes sense to split some controllers, to split some control plane components into separate machines.
If you look at the provider doc that we linked to there, a lot of the construction of the provider doc was based on getting a bunch of feedback from people running big clusters. And in that case, the recommendation is to run a separate etcd plane. But some of that is really, when you're starting to run clusters that size, some of your considerations are, fault tolerance, as opposed to necessarily strict performance. So,
yeah. In general, for resources around scalability, like your one-stop shop would probably be like the 6 scalability docs in the community repo. Yeah. Thanks.
there we go.
Thanks a lot.
All right, thanks.